In this example, we want to form a polynomial with real coefficients having the given zeros, given degree in zeros. So this example, we have a polynomial that has degree 4, so that means that we're going to have 4 zeros. We're given some of those zeros. We have a 3 with multiplicity 2, and so what that means is that 3 is a repeated zero. We have 2 factors of x minus 3. So when we have multiplicity, that means we're going to have repeated factors of the same zero. And then we also have a 0 of 6i. Now this one has that complex 0. And with that complex 0 and the fact that this polynomial has real coefficients, we know that the conjugate negative 6i is also a 0. So this gives us our 4 zeros. We have the 2 repeated 3's, we have the 6i, and using the conjugate pairs theorem, I know I also have a 0 of negative 6i. So this is going to allow me to form the polynomial using all those zeros. So our polynomial, f of x, will be some coefficient multiplied by x minus the 0, and remember, because 3 is repeated, we put 2 factors of that. Because it has multiplicity 2, we have 2 factors of that. And then we have 6i being a 0, so x minus 6i is a factor. We have negative 6i being a 0, so x minus negative 6i is a factor. So we found this polynomial that has the zeros that we're interested in. I'm just going to simplify this last one. Minus and negative is the same thing as plus. So you have 6 plus I. And we're going to simplify it by putting it in expanded form. Right now it's in factored form. I'll multiply these 2 factors together, and I'll multiply these 2 factors together. So x minus 3 times x minus 3 would be x squared minus 3x minus 3x plus 9. Putting x minus 6 times x plus 6 would give me x squared plus 6i minus 6i minus 36i squared. And that would give x squared minus 6i plus 9. And x squared, these middle two are opposites, so they zero out. And that becomes a plus 36 because I squared is negative 1. And negative 1 times a negative 36 would be a positive 36. And I'm going to multiply a little bit more. Now I can multiply these two together. And that would give, let's see, I'll write a bracket here. And I'm going to multiply the x squared times everything over here. That's x squared times x squared plus 36. Then I'll multiply the minus 6i times everything over here. Minus 6i times x squared plus 36. Then I'll multiply the 9 times everything over here. So plus 9 times x squared plus 36. A little bit more multiplying to do. I'll distribute to these parentheses. And that would give x to the 4th plus 36x squared minus 6ix squared minus, and what is 36 times 6? That's 216i. Then I'll subtract. I apologize. I just noticed a mistake I made, and I'm going to correct it because I really shouldn't have any i's in here. So let me highlight the mistake I made. This is a 3x. This should also be a 3x, and when you combine them together, you get 6x. So this should be 3x and 6x. This should be an x. So let's make that correction. So when I distribute, that becomes 6x cubed minus 216x. And when I distribute, I'll have 9x squared, and 9 times 36 gives me 324. I have some like terms I can combine. I can combine these two x squareds together, and I'm also going to write this in descending order, meaning the highest degree first. So I have x to the fourth minus 6x cubed. 36 plus 9 would give me 45x squared minus 216x plus 324. So any multiple of this polynomial would give me these zeros that we listed above. It's a fourth degree polynomial with repeated zeros of 3 and zeros of 6i and negative 6i. Thank you for checking out my videos. Have a great day.